Hi guys, today we want to solve all problems of primary, junior and senior of IMONST International Mathematical Olympiad National Selection Test of Malaysia. And for 2022, after the exam, if you wanted the solution, you can also send me the PDF of your problems after the exam through my WhatsApp number in the description and comments. Also, thanks for seeing this video and please subscribe my YouTube channel and turn on notification for having next videos of Malaysia, USA, and British, Harvard, MIT math tournament. You can use my cards to have them. Primary category, part A, problem number 1. Faris has 6 cubes on his table. The cubes have a total volume of 2021 centimeter cubed. 5 of the cubes have side length 5 centimeter, 5 centimeters, 6 centimeters, 6 centimeters, and 11 centimeters. What is the side length of the 6th cube in centimeters? Okay, so because the total volume is 2021, so the first one 5 is 5 cubed plus 5 cubed plus 6 cubed plus 6 cubed plus 11 cubed, and the thing we don't know is x. Plus x cubed is 2021. So if we calculate, it is 125. It is 125. It is 216. It is 216, and 11 cubed is 121 times 11, which is 121 equals 1331. Okay, if we add up, it will be 250. Here it will be 6 plus 6, 12. We have 1, 1, 1, 1, 3, 2 plus 2, 4. And if we add up all these numbers, 2 plus 1, 3, 3 plus 3, 6 plus 5, 11, 1 plus 3, 4, 4 plus 4, 8, 8 plus 2, 10. We have 1, 1 plus 1, 2. So 2013 plus x cubed is 2021. If you take 2013 to right hand side, it will be 2021 minus 2013, which equals 8. And so we conclude x equals 2. So the answer is equal to 2. Primary part, problem number 2. What is the sum of the first 200 even positive integers? Okay, you say 2 plus 4, first number, second number, third number is 2 times 3 plus 2 times 200. 400. What is sum of that? You factor from 2, it will be 1 plus 2 plus 3 plus 200. And if you replace the formula, it will be 200 times 201, the formula here. There are around 5 important formulas. If you want to learn them, feel free to send a message to my WhatsApp number in the description and comments. 2 times this, it's 20400. So the answer is equal 4200. Primary category, problem number 3, Anushri writes down 5 positive integers on a paper. The numbers are all different and are all smaller than 10. If we add any two of the numbers on the paper, then the result is never 10. What is the number that Anushri writes down for certain? Okay, so the numbers are smaller than 10 and they are positive, so and some of them writes down and some is not 10. So 199 they can't come both, so you can select at most one of them. 2 8 3 7 4 6 and 5. You can select at most one from this part, at most one number, at most one number, at most one number here. So you can select from 1 to 9 except 5, at most 4 numbers, but you select 5 numbers. So it is also, you select it or not, at most 1. So all of them, if you add, it will be at most 5. But because we know selection, we know we select exactly 5, so all of them should change to what? One number from this part, one number, one number, one number equal, and one number from here. Here we have only 5, so we have to select, write down for certain what's the number. The answer is 5. We have to select 5. Primary part, problem number 4. If the time now is 10 a.m., what's the time 1000 hours from now? Note, enter the answer in a 12-hour system without minutes and AM PM. For example, if the answer is 9 p.m., just enter 9. Okay, so if we say, okay, we are here is 10 a.m., 10 plus 1000. So we should consider the remainder when divided by 24 to find AM and PM. But because here, let's divide by 24, I will tell you it's exactly what AM or PM. But if you want only the answer, you can divide by 12. Here it is equal to what? 10, 10. And if we divide it by 24, let's see what we have. 4 times 24 is 96, and we have 50. 2 times 24, 48, so the remainder is what? 2. Okay, so because if you we also consider 10 here, plus this, it is 2 by 24, the remainder is 2. So it is 2 and AM, 2 AM, but you should only enter 2 for this problem. The answer is 2. Primary category, problem number 5. Amina owns a car worth 10,000. She sells it to Nisha. At a 10% profit, Nisha sells the car back to Amina. At a 10% loss, how much money did Amina make from the two transactions in RM? So here you say at first 10,000, she sells what? With 10% profit. So you say 10,000 times 1 plus 10% profit. Here it will be 1.1 and it will be 11,000 she sells. And then, okay, so the first time she gets 11,000, and then Nisha sells the car back to Amina at a 10% loss. So she bought with 11,001 minus 10% because of this. So it will be what? 1 minus 1, 0.1, which is this. And if we calculate that, it will be 9,900. And okay, Amina gets 11,000, and for the second time she wants to buy. So she wants to buy, she should pay 9,900. And if we subtract these two numbers, 0, 0, 9 minus 10, 1, and it will be 0, 10 minus 9, 1. So Amina make 1,100 for these two transactions. Primary part B, problem number 6. Alvin takes 250 small cubes of side length 1 centimeter and glues them together to make a cuboid of size 5 centimeter by 5 centimeter by 10 centimeters. He paints all the faces of the large cuboid with the color green. How many of the small cubes are painted by Alvin? Okay, so if we consider the cuboid, let me draw this part. For example, it is 5, it is 10, something like this. So here it is 5. So suppose here is 5, here is 5, here is 10. So at first I want to calculate only the cubes that are in this part here. Then the other cube that I want to calculate is, so I consider 3 cases. The other cube I want to calculate after that is on this part, on the edges. This part to this part, because they are on 2 faces. And the last part I want to calculate are the corners, because they are on 3 faces. Now, Let's see, here it is 5, so this part, this length is what? This length is 3. And so I say what? I say, okay, this is 3, and also it is what? 8. Minus 1, because the whole part is 10. So you say 3 times 8 for this cube. And how many faces like this 5 by 10? We have 4. You multiply by 4. And then 5 by 5, you say 3 by 3. And how many faces do we have? 1, 2. So we calculate here what the red parts, the cubes here. So I underline with red to understand they are what. Now let's calculate green ones. So green ones, you have 8 cubed here on this edge, so 8. How many edges with 10 do we have? 1, 2, 3, 4 times 4. And edges with 5, we have 3. How many edges of 5 do we have? 8. 1, 2, 3, 4 for this. Also 1, 2, 3, 4. 8. And the last part, let me write with pink. These cubes, how many corners do we have? Here, look, the number of edges. We have 4 plus 8, 12, because we have 12 edges, 4 of them with length 10, and 8 of them with length 5. And the last part, corners. How many corners do we have? 8. So the answer, last answer is what? Let's calculate. 8 times 4, 32. 3 times 32, 96. Plus 9 times 2, 18. 8 times 4 is 32. 3 times 8, 24. Plus 8. So it will be 32. 32 plus 32, 64. 64 plus 96 is 160. Plus 18, which equals 178. So the answer of this problem is equal to 178. Okay, part B, problem number 7. Siku Emma and Siku Tan. Select one integer each. The integers don't have to be positive. The product of the two integers they selected is 2021. How many possible integers could have been selected by Siku Emma? Okay, so the number Siku Emma we call E, the number Siku Tan we call T, and the product is 2021. You should memorize the prime factorization of 21, 22, 23. For this one, we need 20, 21, 43 times 47. So E can be what? Because they are not necessarily positive integer. It can be plus 1, it will be plus 2021. It's negative 1 because the problem says they don't have to be positive. So you can also select negative 2021. And then positive 43. I write positive minus 43, and here it will be positive negative 47, positive negative 47, positive negative 43, and positive negative 2021, positive negative 1. So 1, 2, 3, 4, 5, 6, 7, 8. So Emma can have 8 different answers, so the answer is 8. Primary part B, problem number 8. A 3-digit number is called super B if the first digit is equal to the sum of the other 2 digits. For example, 431 and 909 are super B numbers. How many super B numbers are there? For this problem, we consider hundredths digit. We say if it is 9, then the next number is 09, 1827. It must be equals to sum of them. So 290. So we have how many cases? 10 cases from 0 to 9. For 8, you say 088172880. So we have 9 cases. Now, similarly, go to 202211220, 3 cases, and 101110, 2 cases. So we should add what? 2 to 10. 2 plus 3 plus 4. So one of the most important formula, you can say what? For example, you can say 1 to 10 is 10 times 11 over 2 minus 1 because we don't have 1. It is what? 5 times 11, 55 minus 1, 54. So the answer is equal to 54. Primary problem number 9. It says, let me copy. Given positive integers a, b, c, and d that satisfy the equation for a equals 5, b equals 6d, c equals 7d. What's the smallest possible value of b? Okay, here If you had any question about the solution, feel free to send message to my WhatsApp number. 5b equals 60 equals 70. So here we want to find b. We know 5b is multiple of 4. 5 and 4 are relatively prime. So b is multiple of 4. Similarly, you can say b is multiple of 6. Also b is multiple of 7. So you should consider LCM of 4, 6, 7. B is multiple of them. It is 4 times, you prime factorize, it's 2 squared, 2 times 3, and 7. So it's 2 squared times 3 times 7, which is 4 times 3, 12 times 7, 84. So B should be multiple of 84, and I want to prove 84 works. If you replace B with 84, then it is B. We want to see C will be what? If you divide 84 by 6, it will be what? 114, it will be 70. And 5 times 84, let me tell you, it's what? 5 times 4, 20. 2, 5 times 8, 40, 42. So the last one is 7 times what? 60. D is 60. And here 4 times what is 400? That. So if you divide by 4, it will be 105. So A is what? A is 105. So a smallest b should be multiple of 84. So a smallest one is when b equals minimum b is 84. So the answer of this problem is equal to 84. Primary problem number 10. Find the smallest positive integer and such that the digit sum of n is divisible by 5 and the digit sum of n plus 1 is also divisible by 5. Note the digit sum of 1440 is 1 plus 4 plus 4 plus 0, which is 9. Okay, so we understand the last digit should be 9. Because, for example, look, if we have something like this, the sum of digit here is something. Sum is, for example, s. The next number is, for example, 9, so sum is s plus 1. And s cannot be multiple of 5 and also s plus 1 multiple of 5. Because then their difference, if it is 5k, and it is 5t, then you can say their difference. 1 is 5 times t minus k. So 1 is multiple of 5, and that's contradiction. So the last digit should be 9. I want to see how many 9 should we have. Because look, for example, if you have 2 9 and the sum of this is s, and for example, it is not 9. For example, x less than 9. The next digit will be x minus 1, here 0, 0. So s minus 9 plus 1 minus 9 plus 1. So because they are it is multiple of 5, it is multiple of 5, it is n plus 1, the sum of the digits. So this part, their difference should be multiple of 5. So if you have only 1, if we don't have 1, it will be plus 1, not multiple of 5. Negative 9 plus 1, not multiple of 5. Negative 9 plus 1, not multiple of 5. Negative 3 9s plus 1, not multiple of 5. Negative 4 9s plus 1, which is negative 36, plus 1, which is okay. So if you have 4 9s, it is okay. And this digit should be what? It is 36. So we should place it here 4. And the next digit will be, it is n. And n plus 1 will be what? 5 and 4, 0. So it says what? Find the smallest positive integer. So the answer is 49,999. So problem number 11 of primary, which is problem number 1 of junior. Okay, problem number 11 of primary. Adam draws 7 circles on a paper with radii 1 centimeter, 2 centimeter, 3, 4, 5, 6, 7. The circles don't intersect each other. He colors some circles completely red and the rest of the circles completely blue. What's the minimum possible difference in centimeters squared between the total area of the red circles and the total area of the blue circles? Okay, if we want to consider the radius is or the area will be pi r squared. So the first one is 1, r is 1, so r is 1, 2, 3, 4, 5, 6, 7. So the first one is pi, the second one is 4 pi, this one 9 pi, this one 16 pi, this one 25 pi, this one 36 pi, and this one 49 pi. So we want to select some of them with color, some of them with blue, red. Their difference should be minimum. Now, if I add all of them, 1 plus 4, 5, 5 plus 9, 14 plus 16, 30, 25, 55, 85, 91, 100, 140. There's some will be 140 pi. I want to see, can I reach 0, select some of them that are equal. If I select 49, I need half of that is 70. I need 21. So 21, if I want to select 16, 16 for pi. If I color them with red and the rest of that with blue, so their difference will be 0 and the answer is equal to 0. Primary problem number 12, which is problem number 2 of junior. The number 2021 has a special property that the sum of any two neighboring digit is the number is in the number is a prime number. For example, like 2021, 2 plus 0 is 2, 0 plus 2, 2 prime, 2 plus 1, 3 prime are all prime numbers. Among numbers from 2021 to 2041, how many of them have this property? Okay, so if we consider 2021 is good, we know this part is good, so we should focus on this part. Because we have 2, you shouldn't select even numbers here. So the next one you should check 2023 is good because 2 plus 3 is 5. 2025 is good. 2027 is not good because it's 9. 2029 is good. Now the next one, 2030. So because 3 is odd, so you should place 30. It's good. You should select even numbers. It's good. 20. This part is good. This part is good. You should focus on this. 34 is good, 36 is bad because 9 is not prime, and 38 is good because 11. And the next one, 2040, because this part is not important, 0 to 1, because this part is not prime, so we don't select this. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 good numbers. So the answer is equal to 8. Primary problem number 13, which is junior problem number 3. Clarissa opens a pet shop that sells 3 types of pets: goldfishes, hamsters, and parrots. The pets inside the shop together have a total of 14 wings, 24 heads, and 62 legs. How many goldfishes are there inside Clarissa's shop? Okay, so we consider G is number of goldfishes, so G, and hamsters, parrots. From wings, because we have 14 wings, all the parrots have wing, and each parrot has 2 wings. So because we have 14, we have 7 parrots. And we have 24 heads, each of them have a head. So sum of them is what? 24. And because we have 7 here, we have 17 for this part. Okay, so the number of legs, if we consider is 62, we can say 4 times hamster, 4 legs, and each parrot has 2 legs, 2p equals 62, so 4h plus 2p, 217, 14 equals 62, so 4h equals 62 minus 14, which equals 12 minus 4, 8, 5 minus 1, 4. So h equals what? 12. So if we replace here 12, 17 minus 12 is 5. So the number of goldfishes will be 5. The answer is 5. Okay, primary problem number 14, which is junior problem number 4. A positive integer n is called special if n is divisible by 4, n plus 1 is divisible by 5, and n plus 2 is divisible by 6. How many special integers smaller than 1000 are there? Okay, so n is divisible by 4, so n is 4k. N plus 1 is divisible by 5, so 5, for example, k1, k2. N plus 2 is divisible by 6, 6k3. So I can say n minus 4 is also 4k1 minus 1 multiple of 4. If we subtract both sides, 5 from both sides, it will be minus 5. N minus 4, which is 5, k2 minus 1, we can factor. If we subtract minus 6, 6 from both sides, it will be n minus 4, 6k3 minus 1. So n minus 4 is multiple of all of them, 4, 5, 6. So is multiple of LCM of them, least common multiple of 4, 5, 6, which equals 4 times 3, 12 times 5 times 5, 60. So n minus 4 is multiple of 60, so n minus 4 is 60, for example, s. So we can say n is equal to 60s plus 4. If you have any question about the solution of this problem or other problems, as I said before, feel free to send a message to my WhatsApp number in the description and comments. So let's consider it. 60s plus 4 is less than or greater than equal 1, less than or equal 999. So the minimum s we see that is less greater than equal 0, and if we subtract the 4 from this, it will be 994 over 60, which is 1, and then 39 for 16 point something. So s, because s is integer, that's greater than equal 0, less than or equal 16. So we have 17 answers for s, so we have 17 answers for n. So the answer is equal to 17. Okay, so if we consider from 2020 to 2030, okay, we should consider first day, 1 plus 7, 8th day, and 15. All of them are Wednesday. The problem says what? It is problem number 15 of primary and 5 of junior. Suppose that this decade begins on 1 January 2020, which is on Wednesday, and the next decade begins on 1 January 2030. How many Wednesday are there in this decade? So you say 1, 8, 15 days. So we should see how many days do we have. So 2020 is a leap year, 2024 and 2028 are leap years. So if we consider from 2020 to 2029, we have what? We have 10 years in this decade. 10 years times 365, because leap year, in these leap years, there are 366 days. So one more, plus 3 more. If we calculate, it will be 3650 plus 3, 3. And we should find how many 7k plus 1 do we have? 7k plus 1, because 1, 8, the remainder when divided by 7 is 1. Is greater than equal 1, less than or equal what? 3653. So 7k is greater than equal 0. 3652, and if we divide all sides by 7, k is greater than equal 0, less than or equal 5 times 7, 35, 15, 2 times 7, 14, 12, 1 point something. So k can be from 0, because k is integer, to 5 to 1. So the number of Wednesday that we have from 0 to 5 to 1 is 5 to 1 plus 1, that is this 0. So the answer is 522. Okay, problem number 16 of primary, which is part D, which is junior. Part B, problem number 6. Given an isosceles triangle ABC with AB equals AC, let D be a point on AB such that... Okay, so let's show it on diagram. Okay, here AB equals AC, this part. D be a point on AB such that CD is bisector. So this angle, for example, is x. This angle is also x, because AB equals AC, isosceles is 2x. So it should be 2x. And CB equals CD. CB equals CD. So it is 2x. We conclude it should be also 2x, because these two things are equal. And it says ADC is what? Let me call this one Y. Y is what? So because of this triangle, you have 2x. 2x plus 2x plus x is what? Angles of a triangle, which is 180. So 5x equals 180. So x equals what? 180 over 5, which equals 36. And y equals what? Y equals 180 minus 2x. Here is x. 2x, which is 180 minus 2 times 36, 72, which equals 108. So the answer of this problem, angle ADC, is y equals 108. Problem number 17 of part D, primary, and part B, junior. Problem number 7. So determine the number of isosceles triangle with the following properties. All the sides have integer length in centimeter, and the longest side has length 21 centimeter. Okay, we should see that the numbers we say satisfy triangle inequality with, if you consider any two sides, sum of them is greater than 8. So the longest side, it says, has 21. So we have two types of problems. It's this one. 22 types of triangles, 20, 21. And this one, x, which is at most 21, or these two lines are equal. So we have 21 and something like this. And we have y 21, and y is at most again 21. For this one, you say, okay, 21, 21, x is 1, 21, 21, 2, and we see that it satisfies triangle inequality to 21, 21, 20, and 21, 21, 21. Here, you say, okay, 1, 1 doesn't work because y plus y should be greater than 21. So 2y should be greater than 21. So y should be greater than 21 over 2, which is 10.5. Because they are integers, the problem says the sides are integer here. So y is at least 11. So 11, 11, 21 works. 12, 12, 21 works. 2, 20, 20, 21 works. The last one, 21, 21, 21, is in both of them. So you should count only one. 1 to 20, 20, plus this common triangle, equilateral triangle with length 21, 1. 11 to 20, you say 20 minus 11 plus 1, which is 9, 9 plus 1, 10. 10 plus 20, 30. 30 plus 1, 31. So the answer of this problem is equal to 31. Okay, problem number 18, part D of primary, which is problem number 8, part B of junior. Hafiz marks K points on the circumference of a circle. He connects every point to every other point with straight lines. If there are 210 lines formed, what is K? Okay, if I consider K line points around the circle and try to connect, so 1 is connected to how many? To all of them except itself. So y is connected to 1, 2, to k minus 1. Again, 2 is connected to 1, to this one. If I connect to again k minus 1. So if we see, we say, okay, we have k points. Each of them is connected to k minus 1 other points. We count each line twice. So if we divide it by 2, the answer is 210. So k times k minus 1 is 420, which equals what? 20 times 21. So k is what? K equals 21. Problem number 19, primary part D. Problem number 9 of junior part B. What's the smallest positive multiple of 24 that can be written using digits 4 and 5 only? Okay, because it is multiple of 24, you should prime factorize. 24 is 2 cubed times 3, which is 8 times 3. So if you consider 8, the last 3 digit must be multiple of 8. When the number is multiple of 8, it's also multiple of 4, multiple of 2, it should be. Digits 4 and 5 you can only use. So the last digit, the rightmost digit, should be even because it is multiple of 8, so it is multiple of 2, even number. So you should place 4 here. So this number is 54 or 44. Because it is multiple of 4, 54 is not. For the rule for multiple of 4, you should consider last 2 digit. Multiple of 2, last digit. Multiple of 8, last 3 digits. So 44 is okay. Now, you should consider multiple of 8. If we consider 444, 544. 444 is 4 times 111. It is not good, but it is multiple of 8. It is 8 times, let's check, 6 times 8, 48, 2, 4, 64, 68. So it is multiple of 8. So the last 3 digits should be 544. Now, multiple of 8 is okay. Now we should focus on multiple of 3. It is not multiple of 3. If you consider for 3, you should add the digits. 4 plus 4, 8 plus 5, 13. It is not multiple of 3. We should add at least one digit. If you place 5 here, then the sum will be 18. Sum of the digits, and also 3 will be okay. If you place 4, it's not okay. It's 5, 4, 4. It's not okay. So the minimum number that satisfies the problem's smallest positive multiple of 24 with digits 4 and 5 equals 55, 44. Problem number 2 of 20 primary part D or 10 of junior part B. In a mathematical competition, there are 2021 participants, gold, silver, and bronze. Okay. So we consider the number of golds G, silvers S, bronze medals B are awarded to the winners as follows. The number of silver medals is at least, silver is at least twice the number of gold medals. The first condition. The second, the number of bronze medals is at least twice the number of silver medals. Okay. The number of all medals is not more than, okay, number of all medals G plus S plus B, not more than, so less than or equal 40% of the number of participants, which is 2021. The competition director wants to maximize the number of gold medal. Okay. At first is based on the given conditions. In this case, then maximize the gold. What's the maximum number of bronze medals that can be awarded? Okay, so at first we should calculate this number. 40% is 40 over 100, which equals 4 over 10, which equals 2 over 5. Or let's write 4 over 10 is better. So if we multiply by 4 here, it will be 8084 over 10. So 808. It's what G plus S plus B is at most all medals. And we want to maximize G. We know that B is at least 2S, S is at least 2G. So you can place here S is at least 2G, it will be 4G. So it is at most, B is what? 4G at least. S is at least 2G plus G, which is 7G. Because G is integer, so 7G is less than or equal this. You can say less than or equal 808. You can get rid of the numbers after decimal point. So G is at most, you should divide 110, it's 138, 5 point something. So the number of goals is at most 115. So because it says maximize the number of goals, we consider G is 115. And then because G is 115, we consider G plus S plus B, the maximum number to maximize G also, and after that bronze medal, it's 115. And here it will be what? This minus this. 8 minus 5, 3. 10 minus 1, 9. And here 7 minus 1, 6. So, okay, now we say S plus B is 693 and B is at least 2S. So S plus 2S, which is 3S. So S is at most what? 2. If we consider it's 132. Okay, so here, because we don't want to maximize S, let's use something else. S plus B we know is this. S is at least 2G. S is at least 2G. We maximize GG is 115. 2 times 115 equals 230. So S, because we want to maximize bronze medal here, so we should minimize S. So if we place S 230, so B will be what? If we subtract, will be 3. 9 minus 3, 6. 6 minus 2, 4. And if we check, 4, 6, 3 satisfy this condition. This condition, okay. So the maximum B in this condition that maximize G is 463. If you have any question about the solution of this problem or other problems, as I said before, feel free to send message to my WhatsApp number in the description and comments. Okay, junior part A we've solved in senior part C, and the next page, junior part B, we've solved this in primary part D, all these problems. So we should start from problem number 11 in junior part C, which is first problem of senior part A. It says what? Dinesh has several squares and regular pentagons here, all with side length 1. He wants to arrange these shapes alternately to form a closed loop C diagram. How many pentagons would Dinesh need to do so? Okay, here the formula of, for example, the regular pentagon or square or regular n-sided is sum of the angles is 180 times n minus 2 over n. Each angle will be that. So for square we know it's 90. You can also use this formula. For pentagon you say 5 minus 2 over 5. If you divide it will be 36.3, so it will be 108. So this angle is 90, this angle is 108. So if you want to find this angle, it is x. So x is what? 3. All of that will be 360 minus 90. This one minus 108. So it will be what? 360 minus 90 will be 270 minus 108. 10 minus 8 is 2. 6 minus 0 is 6. And 2 minus 1 is 1. So this angle is 162. It will be a regular, for example, n-sided. We want to suppose it is 1, 2 to m, the last one. So each angle is 180 times m minus 2 over m equals what? Equals 162. So it's 162. This angle is 162 degrees. Now here we can say 180 times m minus 2 equals 162m. And here it's multiple of 9, it will be 20. If we divide both sides by 9, 1, 9, 72, 18. Now we can divide both sides by 2, it will be 10. It will be 9. So 10m, if we multiply, expand minus 20, it will be 9m. Take 9m to the left hand side, 10m minus 9m, m, and negative 20 to right hand side. M is 20, the number of sides, but it says what? Number of pentagons. So alternately we have pentagon and square, so half of that is answered. 20 over, it should be squared. This. So 20 over 2 is 10. So the answer is equal to 10. Okay, problem number 12 of junior part part C, which is problem number 2 of senior part A. It says if x plus 1 over x is 5, what is the value of x cubed plus 1 over x cubed? Okay, so if you raise it to power of 2, x squared plus the first one squared plus 2 times this, which is 2, is 5. So x squared plus 1 over x squared is 5. If we multiply x plus 1 over x to x squared plus 1 over x squared, it will be what? X times this, it will be x cubed, plus x times this will be 1 over x, this times this will be x, plus this times this 1 over x cubed. So x plus 1 over x is 5, and we know it is what? It is 5. This one is, this one, if you take 2 to right hand side, it will be 3. So it will be 3, and okay, our answer, if I call this one, for example, a plus 5 equals 5 times 3, which is 15. So a equals what? Sorry, here I said raise both sides to a power of 2. Let me write again. Raise both sides to a power of 2. Here it will be 5 times 5, 25. So it's 2. Okay, 25 minus 2, 23. So let me correct this part. It's 23. And a plus 5 is 5 times 23, which is what? Which is 5 times 3, 15. We have 1, 5 times 2, 10, plus 1, 115. So A is 115. Take 5 to left hand side, 110. So the answer is 110. Okay, junior problem number 13, part C, which is problem number 3 of part A of senior. And the problem says what? There are 10 girls in a class, all with different heights. They want to form a queue so that no girl stands directly between 2 girls shorter than her. How many ways are there to form the queue? Okay, so if you focus on the tallest girl, for example, suppose girl 1, its height is G2 to G10. So tallest girl should be in the first place or last place, because for example, if it is in third place, so what about these two? The problem says no girls stand between 2 girls shorter than her. So G10 is the tallest, so it's bad to place here. So the last one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The last girl, the tallest girl should be here or here without loss of generality. For example, it is here G10. Then focus on G9. G9 should be in 9th place or this place. So G9, for example, here. Then G8 should be in first or last, G8. So the tallest girl had two cases. The G9 has two first or last. G2 also has two place first or last. G1 only one place is left, so 1. So it will be 2 to the power of 9, which is 512. Okay, problem number 14, junior part C or senior part A, problem number 4. And the two diagonals of a rhombus have length with ratio 3/4 and sum is 56. What's the perimeter of the rhombus? Okay. We know that the diagonals bisect each other. So, for example, if it is B, for example, it is A, it is A, it is B, it is B. For proving these things, if you had any question, feel free, as I said before, to send message to my WhatsApp number in the description and comments. It said the ratio 2B over 2A, for example, here A is a little smaller, 2A over 2B is 3/4. So A over B is 3/4. And sum is 56. So 2b plus 2a is 56. If you divide both sides by 2a plus b will be 28. Now, here, if we cross multiply 4a equals 3b, the problem says what was the perimeter of the rhombus. So if you multiply it by 4, for example, by 3 also, we get 3a plus 3b equals 3 times 28. 3 times 8, 24. We have 2, 3 times 2, 6 plus 2, 84. 3b is 4a, so you can replace it with 4a. 4a plus 3a, 7a equals 84. So if you divide both sides by 7, a is 12. Because a is 12, we know 4a equals 3b. 4a is 48. So b is 48/3, which is 16. Now we conclude that b is 16, this length is 16, this length a is 12. So we want to find perimeter. We know all of them are C. So if we want to find one C, we multiply it by 4 to reach perimeter of this rhombus. So C squared, we use Pythagoras or Pythagorean theorem. C squared equals 16 squared plus 12 squared. And you can factor from 4 squared. It will be 4 squared plus 3 squared. So it will be what? 4 squared times 16 plus 9, 25. 25 is 5 squared. So if you consider square root, C squared equals this. So C equals 4 times 5, which is 21 side. So perimeter equals what? 4 times 20, which equals 80. So the answer of this problem is equal to 80. Okay, problem number 15, junior part C or senior part A. Problem number 5, how many integers n with n greater than equal 1 less than or equal to 2021 have the property that 8n plus 1 is a perfect square? At first, I should tell you an important idea. If a is odd, then you can say a squared is 8 times something, for example, 8k plus 1. The remainder when divided by 8 is 1. It's so much important, useful from qualifying level up to IMO. How we can prove that a is odd? So you say a is 2s plus 1. So a squared is what? The first one squared, 4s squared plus 2 times this, 4s plus 1, 1 squared. If you factor from 4s, it will be s plus 1 plus 1. S times s plus 1, product of two consecutive numbers. One of them is odd, one of them even. So s times s plus 1 is even. So you say it is 2k, 4 times 2k, 8k plus 1. So here we know we should consider the square of odd numbers. Because n is 1, 8n plus 1 will be from 8 times 1 plus 1, 9, less than 8 times this plus 1. 8 times 1 plus 1, 9. 8 times 2, 16. We have 1, 1, 8 times 2, 16. So we have this number. Okay, and if we want to find the how many square root do we have between them? So 3 squared is okay because of this. 5 squared, odd numbers because of this idea, lemma. we can say 5 squared to what squared? So you should find the square root of 1669, and if you want to find that, there is a famous algorithm. You can use that. If you had any question how you can find that, feel free to send message to my WhatsApp number. Here you say, okay, 1 from right, you consider 2 by 2's the digits, 1 times 1 and 61 is left. You multiply it by 2, 20 what times what is good, 22 times 2 is good, 44. This algorithm, you can if you had question about this algorithm, as I said, feel free to send message to my WhatsApp number. So here it's 11 minus 7 minus 4, 7, 5 minus 4, 1. And then we can consider 6, 9 here and 2 here. 12 times 2, 24, 241. You should place same number here. Here we can select 7. 7 times 7, 49. We have 4, 7 times 4, 28 plus 4, 32. We have 3, 7 times 2, 14 plus 3, 17. So it will be 127 point something. So here we should consider until 127 squared. So we should calculate the number of them. It will be 128 over 2 minus 1 because we don't have 1 squared. It will be 64 minus 1, 63. So the answer is equal to 63. Okay, junior part D, problem number 16, which is senior part B, problem number 6. Given a segment of a circle consisting, okay, so let's draw it. Okay, this segment of circle, we have this a straight edge and this arc. The length of the straight edge is 24. If you consider external perpendicular bisector, it passes through O and midpoint. So it says it's 24 AB, so it is 12 is 12. The length between the midpoint of the straight edge and the midpoint of the arc, this part, is 6. Find the radius of the circle. So it is R. The problem says find that. Okay, there is an important, by similar triangles, you can prove this. If you draw an altitude here and this part, there are 3 important rules. One of them is useful here. If you have h, x, y, h squared equals xy. Now here, if I extend this, and if I draw this one, so we know what, because it is diameter, this angle is 90, so like this. It is altitude like h. So h squared is xy, so 12 squared is 6 times, so this one is what? Radius. This one is radius, it is 6, so it is r minus 6. So 6 times r minus 6 plus r. So which is 6 times 2r minus 6. Now we conclude that 2r minus 6 is 12 squared, or 12 times 12 over 6. Divide both sides by 6. 6 to 24. So 2r minus 6 is 24. So 2r is negative 6 to right hand side, 6, 30. So r equals 15. So the radius of this circle is equal to 15. Okay, problem number 17 of junior part D, which is 7. Problem number 7 part B of senior. Sophia has forgotten the passcode of her phone. She only remembers that it has 4 digits and that the product of its digits is 18. How many passcodes satisfy these conditions? Okay, so let's consider the 4 digits. The product of them is 18. All of them are digits. So the maximum one is, let's prime factorize. 18 is 2 times 3 times 3. If the maximum one is 9, and then at first we select what numbers we should have, then I consider arrangements. So 9 the maximum, then the other we have 2. 2, 1, 1. And if you consider the arrangement, it's permutation with repetition. You should know that. If you don't know that, feel free, as I said, to send message to my WhatsApp number in the description and comments to learn that. 4 factorial over 2 factorial, which is 24 over 2, which is 12. And so we can't have 8 maximum number because we have 2. 7 is impossible. 6. If we have 6, 3 is left. 6, 3, 1, 1. Again, 4 factorial over 2 factorial, which is 12. And the next one is 5 is impossible, 4 impossible, 3. If the maximum is 3, so you should have 3, 3, 2, 1. Again, if I write this, it will be 4 factorial, 2 factorial because we have two 3's. It will be 12, so all the cases we've considered. And less than 3 we can't have because 3 is prime. So 12 plus 12 plus 12 is 36. So the answer of this problem is equal to 36. Okay, this problem number 18 is junior part D or senior part B problem number 8. A tree grows in the following manner. On the first day, one branch grows out of the ground. So it is this. On the second day, let me write second day with red. A leaf grows on the branch, this one, for example, and the branch tip splits up into two new branches. Okay, this one and this. On each subsequent day, let me write the third day with green, a new leaf grows on every existing branch. So on this one, on this one, and on this one. And each branch tip, these two, splits up. So here, look, branch tip is only these two. It is branch but not branch tip. It splits up into two. So it is for third day. And it says what? How many leaves? And okay, it says splits up. On each subsequent day, a new leaf grows on every existing branch, and each branch tip splits up into two new branches. How many leaves does the tree have at the end of the 10th day? So we consider until first, second, third day. So let's consider the day, the number of branch tip, and also let's consider the number of branch tip and the number of leaves. Okay, the first day we have, at the end of the first day, we have only one branch tip and we don't have in blue any leaves. On the second day, we say how many new leaves we create. Or here new branch tip. So here two, here new, and if you don't also write that, it's not important. So two we have in second day, red. And how many leaves do we have? So, okay, let's do something. Here we have one branch tip from the previous one. And, okay. We have red, one leaf here, one leaf. And, okay. So, third day, we have 4 branch tips and the number of leaves will be what new leaves? One green and this part, some of them, one and from 2 new, 1 plus 2. And in the fourth day, we have 8 here, but here you should add all these things, 1 plus 2 plus 4. So if I write to the 10th day, here it is twice in each step, 1, 2, 2 to the power of day minus 1. So it will be what? 2 to the power of 9, which is what? 5, 12. The previous one, 9, is 2, 5, 6. And this one is sum of these things here. It will be 1, 2, 2, 2, 5, 6. So if we calculate this one, for example, this one is, let me write 1 plus 2, you can write it 2 squared minus 1. 1 plus 2 squared. It's an important identity. If you don't know that, you should learn this. If you had any question, feel free to send message to my WhatsApp number in the description. 1, 2, 2, 2, 5, 8 is 2 to the power of 8, which is 2 to the power of 9 minus 1. And if we add all these numbers, they will be what? 1. You can consider 1 as 2 to the power of 1 minus 1. So if we add all these numbers here, the first number, sum of that will be 2 to the power of 10 minus 2. How many negative 1 do we have? 2 to the power of 8 to 2 to the power of 0, 9. So it will be what? 2 to the power of 10 is 1024 minus 11, which is 10, 13. So the answer of this problem is equal to 10, 13. Okay, problem number 19, junior part D or senior part B. Problem number 9. Find the sum of decimal digits of the number D. So you say, okay, the first squared 10, 20, 21 squared plus 2 times this 40, 42 times 10 to the power of 20, 21 plus 20, 21 squared. So if I calculate 20, 21 squared, let's calculate is what? 1, 2, this. 2 times this 2404, and this 0 we start from this part. 2404. It will be 144404. Sorry, here 4 plus 4 is 8, so 408 4441. So if I write, and it is what? 10 to the power of 40, 42. If I write these numbers on top of each other, let's see what we have. 10, we have many zeros here, and let me tell you. And this number, I tell you exactly how many zeros. 40, 42, and okay, some zeros, many zeros again. Let me move it to left. I also want to write this number. This number is what? If I write, it will be 1, 4, 4, 4, 8, 0, 4, and it will be 0 here, 0 here. Okay, so this this is some of them. I can do something else because I have 3 numbers. I can move it here and say, okay, this is the third number, it is second number, 0, 0, 0, 0. Okay, so here, how many zeros do we have from this part? Because it is 10 to the power of 2021, it is 2021, and how many zeros do we have here? Is what? 40, 42. So the numbers are not on top of each other. So if we add these numbers, let's see, we don't have non-zero digit number on top of each other. It will be 14444804. Some zeros, you can calculate the number of zeros here. It's not important in this problem. And this one will be 2404. Some zeros, and then here 1. So sum of digits will be what? 1 plus 4 plus 0 plus 4 plus 2 plus 4 plus 8 plus 4 plus 4, 3 fours plus 1. 1 plus 4, 5. How many 4s do we have? 1, 2, 3, 4, 5, 6. 6 4s, 24. How many? So let's calculate the number of other digits. 1 plus 2, 3. 3 plus 8, 11. 11 plus 1, 12. So it's 12. And 12 plus 24 is 36. So the answer of this problem is equal to 36. Problem number 20, junior part D or senior part B. Problem number 10, determine the number of integer solutions x, y, z which are between 0 and 100 for the equation this. So we can expand this: x squared plus y squared minus 2xy plus y squared plus z squared minus plus 2yz equals x squared plus y squared plus 2xy plus y squared plus z squared minus 2yz. So you can cancel x squared, you can cancel y squared from both sides, you can cancel again y squared from both sides, and this z squared from both sides. You can divide both. Here we have negative 2xy, here we have plus 2xy. Negative 2yz, 2yz. So take negative 2yz to left hand side, it will be 4yz. Take negative 2xy to right hand side, 2xy plus 2xy, 4xy. So we conclude what? Yz equals xy. Here you can't cancel y from both sides because maybe y is 0. But we can say what? If we take all things to left hand side, yz minus yx equals 0. So you can factor from yz minus x equals 0. And then we can say what? We have two cases. In how many cases y equals 0? In how many cases z minus x equals 0, which is equivalent that z equals x. And we should subtract the common cases because we count them twice. How many cases y is 0? So y has one case only, y is 0. X has 101 cases because 0 to 100 is 101. And z has 101 cases, so 101 squared. Here, you can say, okay, z has 101 case. x has one case because equal to z, and y has 101 cases. So here it's 101 squared. Now we should subtract. Add this and subtract the cases that y equals 0 and this part, and z equals x, this part. You say, okay, it is what? Y equals 0, so y has one case, z has 101 case, and x has one case because it equals z, so 101. So the answer is what? 101 squared plus 101 squared minus 101. And if you calculate 101 squared, it will be what? Let's calculate. 101, 101, it is 101, 01, 101, it is 10201. So it will be 10201 minus 101, 1 minus 100 minus 00, 2 minus 1, 1, 0, this. And we have two this. 101 squared, 2 this. So let's multiply by 2 this one. So it will be what? If I multiply by 2, it will be 20402. Because 101 squared is this. We have 2 of that. We should multiply by 2, 20402. So now if you subtract 2 minus 1 is 1, 0, 0, 4 minus 1, 3, 0, 2. So the answer is equal to 20,301. Okay, senior part A, we've solved this. In junior part C, we can ignore them. Senior part B, we've solved all of them in junior part D. So now we should solve senior part C. And okay, senior problem number 11. Given 2 points A and B and 2 circles gamma 1 with center A passing through B, and gamma 2 with center B and passing through A. Line AB meets omega 2 at C. Point D lies on omega 2 such that CDB is 57. So let me consider these. And okay. So this is 57, and it says BD meets omega 1 at what point? At point E. What is CAE? Let me connect. What is this angle? Let me call this angle, for example, x. So here we know the center is this, so it is radius, So it is what? 57. And we can say what? 57, we want to find this angle. 180 minus 2 times 57. 2 times 57 is what? 2 times 7, 14. We have 1, 2 times 5, 10. 1, 114. 10 minus 4 is 6. 7 minus 1 is 6. So it is 66. So this angle is 66. Now, it is center. This is radius. So this is equal to, also it is equal to this. This is equal to this, but it is not radius B. Because it is E is on omega 1, B center of omega 2. So here it is 66, it should be 66, and the problem says x is what? 180, some of the angles of this triangle, ABE, minus 2 times 66. 2 times 66 is 2 times 6, 12. We have 1, 2 times 6, 12, plus 1, 13. 180 minus 32, which equals 58, which equals 48. Problem number 12, senior, determine the number of positive integer solutions x, y, z to the equation this. Okay, for this problem, x, y, z equals 2 x, y plus z if x, y, all of them are greater than equal 3, then you can say what? The left side is 27, the right side is 2 times 3 plus 3 plus 3, which is what? 2 times 9, 18. And this one is greater. And if you add each of them, for example, look, it is x, y, z. It is 2 times x plus y plus z. If you add, for example, x by 1, x to x plus 1, the left side will be add by plus yz. The right side will be add by plus 2. And because y and z are greater than or equal to 3, so always left side will be greater than right side, strictly greater than right side. So at least one of them is 1 or 2 because they are positive integers. Without loss of generality, suppose that z is 1, or in case 1, in case 2, z is 2. So, because they are symmetric. X, y, and z. If z is 1, you can replace in the main equation. So xy equals 2 times x plus y plus 1. So you can say xy minus 2x minus 2y equals 2. And we can write x minus 2, y minus 2. Here it is xy minus 2x minus 2y plus 4. So you add 4 also to right side, 6. Now here, because x minus xy are positive integers, x minus 2 is at least 1 minus 2, negative 1. So here are both of them. If we consider negative 1, the only possible cases are 1, 6, and 2, 3. Because if we consider negative 2, negative 3, we can't have that. Negative 1, negative 6, we can't have that because of negative 6. So for this one, x is 3 and y is 8. For this one, x is 4 and y is 5. And so our answers are what? 1, 3, 8 and 1, 4, 5. So you should check always in the main equation at the end. 2 plus x plus y plus z here. In the first term, left side is 24, right side is 2 times 8 plus 3, 11 plus 1, 12. Is it okay? This one. 4 times 5 times 1, 20. 1 plus 4 plus 5, 10. And 2 times 10, 20. So it is also okay. So we found 2 answers, but you should calculate the permutation. 3 factorial 6, 3 factorial 6. So here, until here, we have 12 answers. Case 2, z equals 2. Z equals 2, so 2xy equals 2 times x plus y plus 2. So you can cancel both sides by 2. Xy minus x minus y is 2. So you can say x minus y times y minus y equals 3. So the cases are 1, 3, and 3, 1. And we don't need to write like here 3, 2, 3, 1 because we calculate permutation at the end. So x is 2, y is what? Y is 4. So the answer is 2, 2, 4. Here, because we have 2 to 4, the number of permutation will be 4 factorial over 2 factorial, 3 factorial over 2 factorial because we have 2 2's, 3 factorial over 2 factorial, 3. So the answer is 6 plus 6 plus 3, which is 15. So the last answer of this problem is equal to 15. Okay, problem number 13 of senior. Okay, so Jasmine has a mobile phone that runs on a battery. When the battery is dead, it takes 2 hours to recharge it fully if she is not using the phone. If she uses the phone while recharging, 75% of the charge obtained is immediately consumed and the remaining is stored in the battery. One day, her battery died. Jasmine took 2 hours, 30 minutes to recharge the battery fully. For how many minutes did she use the phone while recharging? So, if we consider the period, for example, 2 hour and half. So 2 hour and half is how many minutes? 2 times 60 plus 30 is 150 minutes. So consider, for example, he used this part and the rest doesn't use 150 minus u. Okay, we know that it says in 2 hours it can charge the battery, but you shouldn't use. So 100%, we want to see in each minute it charges how much of that. 100% over 120 minutes for each minute. And it says if she uses the phone, only 25% will stored because 75% consumed. So here she is using the phone, so we can say what? U times 100% because U minutes times 120 times 25% of that plus 150 minus U doesn't use 100% over 120. It should be 100%. Okay, now we want to find what? We want to find U, the problem says. So you can cancel, divide both sides by 100%, which is 1. Then we can multiply both sides by 120, 25% is u over 4 plus 150 minus u. We multiplied by 120 both sides, so it will be 120. Now you can take 120 to left hand side and u negative u to right hand side, u minus u over 4, which is 4u minus u, which is 3u over 4, and it's equal to 30. So if we divide both sides by 3, it will be 10, so u equals 40. So the answer is equal to 40 minutes. 40. Senior problem number 14, given a function p of x equals ax5 bx4 cx3 plus dx2 plus ex plus f. Each coefficient a, b, c, d, e, and f is equal to either 1 or negative 1. If p of 2 is 11, what's the value of p of 3? So here x p of 2, if you consider p of 2, it will be what? You should replace x with 2. 32a plus 16b plus 8c plus 4d plus 2e plus f. And if I replace, it says a, b, c, d, e, f are plus 1 or negative 1. So because it is 11, so 32, if 30, all of them, if you consider negative 1, it will be negative 31. Okay, so if you consider it is, or positive 31. If you consider it is negative 1, it will be negative 32, and the answer will be negative 1. So a should be plus 1. Now, if you consider plus 1 for this case, it will be 48, and if you consider all of them negative 1, it will be greater than 11. So this one will be negative 1. Until here, we have what? 16. If 8 is positive, so 8 is C is positive 1. 24 minus all of them won't reach 11, so it should be what? Negative 1. So 16 minus 8 is 8. And now we understand that it should be 3. Because 8 plus 3 is 11. So if D is negative 1, then if all of them plus 1, it will be negative. So it should be plus 1. And it will be plus 4. So 4 plus what is 3? Negative 1. So the only possible case is that this one negative 1, this one plus 1. So we found P of x is what? P of 3 is what? 3 to the 5 times a, which is plus 1, 3 to the 5. It's negative 1 minus 3 to the 4. It's negative 1 minus 3 cubed. It's positive 1 plus 3 squared. It's negative 1 minus 3. It's positive 1 plus 1. 3 to the 5 is 243 minus 3 to the 4, 81 minus this one, 27. Plus 9 minus 3 plus 1. So we want to calculate that. Let's see, it will be what? 9 minus 3, 6, 6 plus 1, 7. It will be negative 20. It will be negative 101. And 3 minus 1, 2. 4 minus 0, 4. 2 minus 1, 1. So the answer, P of 3 equals, answer of the problem, 142. Okay, problem number 15 of senior. Find the sum of all integers n with this property. Both n and n plus 2021 are perfect squares. So n is x squared. And without loss of generality, you can consider x is at least 0. N plus 2021 is y squared. Again, without loss of generality, you can consider y greater than or equal to 0. If you consider the difference, 2021 is equal to y minus x, y squared minus x squared, which is y minus x, y plus x. Because both of them are greater than or equal to 0, so it is an greater than or equal to 0 because it is not 0. If it is 0, the product will be 0. So it is positive because the product is positive, it should be also positive. Now, 2021 is what? 43 times 47. So if we want to consider the cases, we can say it is this one is less than or equal to this one because x is at least 0. So we should consider one 2021, the next one 43, 47. For first case, if you add up these two numbers, 2y will be 2022, 2022 over 2 will be y, which is 10, 11, and x will be what? Y minus x is 1, so x is y minus 1. Y minus 1, x is 10, 10. The next one, so we found one answer. Y is this, n is this, and it says n is what? N is what? N is x squared. So for this case, n is 110 squared. And the next case, 43, 47, if you add This because we want to find only x, let's subtract. 74 minus 47 minus 43 is 2x because y will be cancelled. 2x is 47 minus 43, which is 4. So x is 2, so n is 4 in this case. The problem says what? Find the sum. So the answer is 10 squared plus 4. And if we multiply 101, 101, 101, 101, it's 102, 101. And if you add by 4, 10205. Here we consider only 101. We have two zeros. So let's add them at first. We say, okay, it's 10, 201, and two zeros are left, plus 4. So if we add, it will be 102, 101, 04. Okay, so the answer is equal to this number, 10, 20, 104. Okay, given a square ABCD with side length 6, we draw line segments from the midpoint here of each side to the vertices on the opposite side. For example, we draw line segments from the midpoint of side AB like this. Here, for example, let me call this one M. Two vertices C and D. Okay, so let's consider M, M, K, L. Their midpoint, so all of them are 3, 3, 3, 3, because side length 6 here. The 8 resulting line segments together bound an octagon inside the square. This one it means. And the problem says what's the area of this octagon? So we want to find the area of this part. So here we can use several ways. One way I want to use here is consider this triangle, and then we want to subtract the bad areas we don't want. Let me minimize a little. This one, this one, this one, this one, the first area that we have twice from that. Similarly, it is equal to that, this one, and the others, let me write with, for example, brown, or with, I can also write with red. So the next one is this triangle, these sides, all of them if you consider also this triangle. So because we have both of them are equal, we need to calculate only one of them. So the first one, the largest triangle, the height is 6, it is 6. So 6 times 6 over 2 minus the red one. We want to find the area, because if you consider it is 3, it is a rectangle, this part. So the diagonals bisect each other. And if you draw this, these two triangles are congruent, and the height of this triangle will be what? Will be 3, exactly equal to this. So it's 3, we say 3 height times 3 over 2, but we have two triangles, minus 2 times 3 over 2, minus it is red parts, and now we want to find green parts. So here for green parts, we want to consider what? This part, and because it is midpoint by Thayer's theorem, it is 3 over 6. Also, this is what, if we calculate, this is half of 3, so it is 3 over 2, this length. Let me call this one T. So KT is what? 3 over 2. Now we want to calculate K, for example, KF. So if I want to calculate KF, I use Menelaus's theorem. If you don't know these things, there are around 40 important ideas. If you learn them, it is useful from qualifying level up to IMO. If you had any question about that, as I said before, feel free to send message to my WhatsApp number in the description and comments. So I want to find length KF. I use Menelaus's theorem for triangle BKC and a straight line NFD. So here BF over FK times DK over DC times CN over NB equals 1. Cn over Nb is 1, dk is 3, dc is 6, so it's 1 over 2. So we conclude what? We want to find kf. Bf is 2fk. We know bk is what by Pythagoras theorem? Bk squared is 6 squared plus 3 squared. So it will be 6 squared plus 3 squared, which is 36 plus 9, 45, which is 3 root 5. And because bf is 2fk, we can say, okay, it is twice this, so it is 1/3 of all. It is, for example, y, 2y. It is twice this. So kf is 1/3 of bk. So kf or fk is 1/3 of bk, which is 3 root 5, which equals root 5. So we conclude kf is root 5. For finding this area of this part, we should find the area of this and multiply it by 2. Also, because we want to calculate this, multiply it by 4. So we say 4 times area of this part, ktf. If I consider this is alpha, and if I extend this, sine alpha is 3 over this. So we conclude sine alpha is opposite side 3 over bk. Bk was what? Was 3 root 5, which is 1 over root 5. So the area of this part, the formula, you should know this formula about area. This side times sine of that over 2. So it will be 1 over 2 kt kf. It's 3 root 5 over 2, 3 root 5 over 2 times sine alpha, which is 1 over root 5. And they will be cancelled. Here, these 2 will be cancelled. Minus 3. So the answer will be what? 36 over 2, 18. Minus 9, minus 3. It will be 18 minus 12, which is 6. So the area of this octagon is equal to 6. If you had any question about the solution of this problem or other problems, as I said before, feel free to send a message to my WhatsApp number in the description and comments. Problem number 17 of senior: determine the sum of all positive integers n that satisfy the following condition. When 6n plus 1 is written in base 10, all its digits are equal. So let's consider n1. Then 6 plus 1, 7 is okay. N2, 6 squared, 36 plus 1, 37 is bad. N3, 6 times is 26 plus 1, 2017 is bad. N4, we check until N5. So considering small examples most of the time are useful. 6 times is 36, we have 3. 6 times 1, 6 plus 3, 9. It is this plus 1, 1, 2, 9, 7 is bad. If you consider also N5, 6 times 6, 36, 3. 6 times 9, 54 plus 3, 57. We have 5. 6 times 2, 12 plus 5, 17. We have 1. 6 times 1 plus 1, 7 plus 6, which is 77, 77. Okay, we want to prove that only these two are answers, n1 and n5. If n is greater than equal 6, so we know our number 6n plus 1 has at least, because the last digit, if you want to consider last digit, you should consider mod 10, and is 6 plus 1, 7. You should know congruency for this problem. If you had any question about congruency, as I said before, feel free to send a message to my WhatsApp number in the description and comments. So because 7, so all the digits should be 7, because the problem says digits are equal. So 6n plus 1 has at least, because n is at least 6, so it is greater than this, has at least 5, 7. 1, 2, 3, 4, 5, 7. It means what? 6n plus 1 mod 10 to the power of 5 is 5 sevens. 1, 2, 3, 4, 5. And this one, if we consider mod 2 to the 5, 6n plus 1 mod 2 to the 5, also we can write 5 sevens. And here we can say what? We can say 6 to the n, because n is at least 6, is 0. So you write 0 and take 1 to right hand side, it will be 77776. So mod 2 to the power 5 is 32. So this number should be multiple of 32. But if we check this number, for example, mod 8, we should consider only last 3 digits. Mod 8 is what? 9 times 8, 72, and it's 56. So it is multiple of 8, and also it should be multiple of 32. So let's divide by 32 here. 77776. When divided by 32, let's move down this number. Okay, so here, if we divide this number, 2 times 32, 64, 317. Then I should place what? 5 times 4, 8, 4, 128. It has 279, and then 97. 3 times this, 96, 1, 6. Okay, so here you place 0 here, 0, and this one, it will be what? 5. So it is not multiple of 32, and that's a contradiction. So here we found the only answers are n1 and 5, and the problem says what sum of them. So the answer is 1 plus 5 equals 6. Problem number 18, senior, how many real numbers x are solutions to the equation absolute value of x minus 2 minus 4 equals 1 over absolute value of x minus 3? Because 2 is important for this, 3 is important. So we should consider these 3 intervals. If x is greater, because x is not 3, because the denominator will be 0, x is greater than 3, x minus 2 minus 4 equals 1 over x minus 3. And so x minus 2 minus 4 is x minus 6 equals 1 over x minus 3. If we cross multiply x minus 6, x minus 3 will be 1. And if we simplify x squared minus 3x minus 6x minus 9x plus 18 minus 1 plus 17 equals 0. And if we find the roots, x equals 9 plus minus 81 minus 68 over 2, which is 9 plus minus 81 minus 68, 2, 11 minus 8, we can say 3, 7, 13 over 2. It should be greater than 3. 13 is 4 point something. 9, 1 minus 4 point something is 5 point something. Around 5 over 2, 2.5. It is not greater than 3. And you can easily prove with inequality, but 9 plus this is okay. So the first answer is 9 plus root 13 over 2. One answer here. We should find the number of answers. If x is between 2 and 3, greater than 2, less than 3. So here it will be x minus 2 minus 4, x minus 6. And this one will be 1 over 3 minus x. If we cross multiply x minus 6, 3 minus x equals 1. So if we multiply minus x squared minus x and minus plus 6x plus 5x and minus 18, and it will be minus 19 if you take it to left hand side. X squared minus 5x plus 19 equals 0. Let's calculate this part. If I write the roots, it will be x equals 9 plus minus 81 minus 4ac minus 76 over 2, which will be 9 plus minus root 5 over 2. So the answer must be between 3 and 2 if you consider plus. Let's check. It is around 2. 9 plus 2 is greater than 2. 9 plus 2 is 11 over 2 is around 5.5. It is not good. 9 minus root 5 is good. Let's prove it. 9 minus root 5 over 2, it is less than 3. It's obvious because 9 over 2 is 4.5. And if you want, we can also check this. Let's check this part. If we multiply by 2, it will be what? It will be 4. 9 minus root 5 less than 6. So if we simplify this, root 5 greater than 3. Okay, so let's see this. No. This part, we have reached contradiction. Now let's consider 9 plus root 5 because we have divided by 2. I think it's okay. So let's check. Is it greater than 2, 3? If we multiply by 2, it's 4. 9 plus root 5 less than 6. And Okay, so if you want to prove this part, okay, so we will see also it is bad because 9 is not, this is greater than 6. So here, let me write contradiction. We've checked both of them, so we've reached contradiction for this case. Now let's consider the last case. X is less than 2, and if we use that here, X is less than 2, and okay, so here it will be 2 minus x minus 4 equals 1 over 3 minus x. It is what? Minus x and minus 2. So if I multiply both sides by negative 1, x plus 2 equals 1 over x minus 3. And if we cross multiply, it will be x plus 2 times x minus 3 will be what? Will be 1. So x squared minus 3x plus 2 minus x minus 6 minus 7 equals 0. And if you use quadratic formula, it will be x equals negative b1 plus minus b squared minus 1 plus 28 over 2, which is 1, negative 1 plus minus 29 over 2. If you consider plus, it will be 5 point something minus 1. It will be 4 point something over 2. It's greater than 2. So plus is not good. Now we should check minus is good because it's negative and less than 2. So we found second answer. So the number of answers is equal to 2. Because the problem says how many answers do we have? We found this answer. We found 2 answers. This answer and this answer. The problem says how many real numbers x are the solutions. Problem number 19, senior. A company has a secret safe box that is locked by 6 locks. Several copies of the keys are distributed among the directors of the company. Each key can unlock exactly 1 lock. So we have 1, 2, 3, 4, 5, 6 locks. Each director has 3 keys for 3 different locks. No 2 directors can unlock the same 3 locks. No 2 directors together can unlock the safe. So, for example, if you have 1, 2, 3, we can't have 4, 5, 6. Okay. So if we consider what's the maximum possible number of directors in the company? So you say 6 choose 3, the number of subsets with 3 elements. 6 times 5 times 4 over 3 times 2. You cancel 20. If you write all of them 1, 2, 3, 1, 2, 4, then the rest will be what? 3, 5, let me check 1, 2, 4, 3, 5, 6. Yes. So from each of them, you can select this or this because of this condition. No 2 directors together can unlock the safe. So we have 20, but we have how many groups? Until 10 groups. So you can only select 1, 2, 3, 1, 2, 4, 2, all of them like this. And the last one is 1, 5, 6 here, 2, 3, 4. So the answer, you can only consider the threes that have 1, 1, 2, 3, 1, 2, 4. Then you don't select like this. So the answer of this problem is 10. At first we prove from each of them you select at most 1. But then you select 1, 2, 3, 1, 2, 4, 1, 5, 6. And it's 20 over 2, 10. If you had any question about the solution of this problem and other problems, as I said before, feel free to send message to my WhatsApp number in the description and comments. Problem number 20 is senior, the last problem. The cells of a 2021 by 2021 table are filled with numbers using the following rules. So let me write 2021, 2021. Okay. The bottom left cell, which we label 1, 1, contains the number 0. Okay. For every other cell C, we consider a route from 1, 1 to C, where at each step we can only go 1 cell to the right or 1 cell to the up, not diagonally. If we take the number of steps in the route and add the numbers from the cell along the route, we obtain the number in cell C. For example, the cell with coordinate 2, 1. So if you want to reach from this one step, and the cells in this root is 0, the sum of them. 0 plus 1 step is 1. Similarly, it is 1. And the next one for 3, 1. You say, okay, if you go this direction, 0 plus 1, 1, and 2 steps. So 2, you add all of them together. It will be 3. Similarly, it will be 3, it will be 3. If you consider, okay, it says until here, and the cell with coordinate 3, 2. Okay, so let's count it. 1, 2, 3 steps, and the sum of them is 1 plus 3, 4 plus 3 steps, which is 7. So when it is 7, it is 7, it is 7, it is 7. And it says what's the last digit of the number in the cell 2021. So if we calculate that, the first one is 0, the 1, 3, 7. We consider only last digit. This one, you say, okay, 7 plus 3, 10, 10 plus 1, 11, 1, 2, 3, 4 steps. 4 steps plus 1, let's write completely 15. And the next one, you say what? You add all of them, 15 plus 7. So let's consider only last digit, 1, 3, 7, 5. Okay, here, if we want to, we found it is 5. And okay, you say the next one, 1, 2, 3, 4, 5 steps. 5 steps plus sum of all of them. 5 plus 5, 10. 10 plus 7 is 17. 17 plus 3, 20. 21. It is 1. And if you check, the next one will be 3, 7, 5. And we can prove it with recursive sequence. It is more useful in round 2, but if you want to know exactly it is what, I say, okay, consider, for example, it is what? It is A1, it is A2. AN is what? Is AN minus 1, for example. A3, A4, A5. So AN is sum of all of them to A1. And for example, for this one, A4, you say, okay, 1, 2, 3 steps. 4 plus N minus 1 steps. And if you calculate, let's write also for AN plus 1, if it will be AN to A1 plus N. And if you subtract N plus 1 minus AN, will be AN plus N minus this will be 1. So AN plus 1 is 2 times AN plus 1. If you don't know recursive sequence, you should learn that. And if you wanted to know how you can solve recursive sequence, is useful from qualifying level up to IMO. Then because recursive sequence, you can say this period will be repeated 1, 3, 7, 5, 1, 3, 7, 5. So because the first one we shouldn't consider that. You say 2021 minus 1, and you should consider it mod 4 or divide it by 4. It is 2022 and the remainder is 0 when divided by 4. So it will be what? 1, 2, 3, 4. It will be this. So it is like 5, this one. So the answer of this problem is equal to 5. Okay, I released all solutions of primary, junior, and senior of 2021. I also will release 2022 solutions after the exam. So if you wanted to that I release quickly the solutions, if you wanted, you can send me the PDF of the problems of 2022. After that, after the exam, I will immediately release solutions of 2022 of IMONST for Malaysia. Okay, so please subscribe my YouTube channel to have next videos. Thank you for seeing this video, and you can use my playlist. I will release mathematical Olympiad problems of USA, America, British, Harvard, MIT math tournament problems, and you can improve your problem solving.